So we mostly did revision for AS reaction kinetics yesterday, and we had started talking about rate. Okay, we had started talking about rate of reaction, and I told you how do you measure rate. I told you that it's any change that you measure with respect to time, like how fast is that change happening, and that change could be anything. It could be mass, concentration, volume, pressure, color, any observable change, measurable change with respect to time. So ये वाला हम कर रहे थे, I told you that if you have this reaction, how could you measure the speed of the reaction? You can measure any change. How quickly does Mg dissolve? So you can plot the mass of Mg, and you can plot it with respect to time, and you will see how quickly it's changing. Or you can check how quickly the pH changes because it's an acid, and it will become less acidic over time. How does H2 gas, the volume of H2 gas, you can plot that volume of H2 gas. It's going to increase and then it's going to become constant. And you can also check how does the mass, you can talk about the mass of the solution. So you can plot any change with respect to time. It could be a decreasing change. It could be an increasing change. So we're not interested whether the gradient is negative or positive. We're just interested in the value of the gradient. So the gradient of this graph is the rate of the reaction. Okay, that tells you how fast something is happening. अब इससे आगे continue करते हैं. You've got so this is how you're going to measure rate. Okay, that's any change with respect to time. It's basically the gradient of that particular graph. Now, what I'm going to discuss next is order of reaction. So we're going to talk. Okay, let me make this. So we're going to talk about what is order. Okay, so this is what is order. That's what we're going to discuss. And sorry. Just hold on a second. They've actually changed the layout of the board. मैं जरा size check कर रहा हूँ. So this is fine, I guess. So order of reaction. Okay, what is meant? So what is meant by this term? Okay, what does it refer to? Now order of reaction is that whenever you have a reaction, you've got 2-3 reactants and they're reacting together with each other. So let's say you've got reactant A, and that reactant A is reacting with reactant B. Let's say there's just 2 reactants, and they're going to produce some product, and let's call that product P. Okay, so normally let's say there's just 2 reactants. You could have more than 2 reactants. You could have 4 reactants. You could have 5 reactants. There could be just a single reactant. So what will happen is there'll be a bunch of particles of A, and so let's say they are particles of A, and they are particles of B. And these two are going to collide, and there's going to be a reaction between them. So A will react with.
So have we only just started now?
We've just started. Okay. So A will react with B, and there's going to be a reaction. Now, so the speed of the reaction. Remember, we talked about 5 factors that affect the speed of the reaction. These were the 5 factors. That one of them was temperature, the other one was pressure. You had concentration, and you had surface area, and a cashless as well. Now, right now, I'm only interested in concentration. And for gases, remember, concentration and pressure is directly proportional. So at the moment, we are only interested in only one thing, and that's concentration. So what will happen is that if I increase the concentration of, let's say, B, my reaction will speed up, right? So, and similarly, if I increase the concentration of this of A as well, the reaction would speed up. So that means the rate of the reaction, it depends on the concentration of A, and it depends on the concentration of B. Okay, so there's some relationship that if you increase the concentration of B, you'll have more collisions and the reaction will be faster. And if you increase the concentration of A, there'll be more collisions and the reaction will be faster. So the rate of the reaction depends on the concentration of both reactants. Okay? So does this expression make sense? Hani, clear? Does this make sense? Alicia, everyone else, Bilal. Because everything is now going to be about this expression. So it's pretty obvious that the rate of the reaction depends on the concentration of the reactants. It doesn't depend on the concentration of the products because products have nothing to do with the reaction. Once they're formed, they don't do anything. So it's all about the collisions of these two particles. You reduce the concentration of B, the number of collisions will decrease and the reaction would automatically slow down. So now if we focus on this equation, now this expression is known as the rate equation. It's known as the rate equation if I get rid of the proportionality sign. Plus there's one other thing in the expression, and that thing is that that there's going to be a power. X and Y will have a power. B will have a power of Y. This X and Y is the exponent that is used, and that's your order. So when you refer to the word order, that's the power. X and Y are the orders of a reactant in a rate equation. Now I'll explain what order is. But remember technically, mathematically, what is X and Y? That's order. Okay, so they're not constant. Yeah, you would have to put a constant to get rid of the proportionality sign. So I'm going to do that right now. So what I'm going to do is I'm going to put get rid of the proportionality sign. So you would have to introduce a constant, and that constant is known as the rate constant. Because that's your that's a rate constant. Anyways, coming back to this. So for any reaction, I'll have a rate equation where I'll have different reactants. The rate will be dependent on the concentration of those reactants. There's going to be a constant because you have to get rid of the proportionality, and there's going to be a power for each concentration. I'll explain the power. Now, what this power represents, what does it represent? Let's say, for example, I write that rate depends on the concentration of A. That's one of my reactants. And it's got a power X. Okay, let's try and investigate this. Okay, let's isolate this. This is what I said, that if I increase the concentration of A, the rate of the reaction will speed up. So rate depends on the concentration of A. What this X represents is we are not sure how it depends on that. Okay, so this X defines what that relationship is. This X could have a power of 1. That's known as order 1. So order 1 means, so let's start with order being equal to 1. So what does that represent? So order 1 represents that in this case, X will be equal to 1. And if X is equal to 1, that means the rate equation will be that the rate depends on the concentration of A and the power is 1. So what this represents is that the rate depends on the concentration of A, but it's directly proportional. Power 1 means you double the concentration of A, the rate of the reaction will also double. Okay, so that's a linear relationship, So the first one over here, order 1, means you've got it's directly proportional. Because this one is right. So this is direct proportionality. And we can come up with a graph that the graph would look something like this, and it's going to be a straight line. So that's your straight line. And on one side, we can have the rate. And on the other side, we can plot concentration. So that is one graph. That's the relationship. You keep on increasing the concentration of A, the rate keeps on increasing in a reaction, and it's a straight line. Okay, is this clear what order 1 is? Is this part clear? To everyone. So just the idea that you'll have many reactants, whether it's A, whether it's B, you can have many reactants. The order represents what is the relationship. Rate depends on the concentration of A. How does it depend on that? So order 1 is that it depends, it's directly proportional to the concentration of A. You change concentration of A, the rate will increase. Then you've got order 2 as well. So order 2 is this thing. That says, what is order 2? Order 2 is now in order 2, what will happen is that the rate will depend on the concentration of A. Okay, so the rate will depend on the concentration of A. You change concentration of A, rate will get affected. But the power over here is 2. So that means, so that's a different relationship. That's a nonlinear relationship. What this suggests, what is this suggesting? It's suggesting that you change the concentration of A. If you, let's say, double concentration of A, and for concentration, I'll be using square brackets. So I'll just, so if you double concentration of A, the rate quadruples. That is what is meant by that. Similarly, if you triple the concentration of A, the rate is 9 times or increases 9 times. So by 9 times, it's going to increase. If you reduce the concentration of A, So A's concentration becomes half. The rate becomes 1/4. It slows down. So whatever you do to the concentration, Bilal, I didn't get what you meant by order is this power on the concentration. Like we're going to state that rate depends on the concentration of A. This is order. That's known as order. The power over here, that's your order. Bilal, is that clear? That's your order. It could have a value of 0. It could have a value of 1. If it has a value of 1, that means there's a direct relationship. That means the rate is proportional to the concentration of A with the power 1. 1 is the order. And that represents a linear relationship that you change concentration of A and the rate increases. That's a different story. Right now, I'm just introducing order at the moment. So we're going to explain and go into a lot more detail, like how do you figure that out? Okay, right now, I'm just introducing what order is. Okay, so you've got, and you must know what it means. So you've got order 1, you've got order 2. So when you see order 2, like how do you figure that out? That's a different story. We'll talk about that later. So when you figure out order 2 means the relationship is this. And also it also means that, remember this, like order 2, this relationship indicates that if you decrease the concentration by half, the rate will decrease by 1/4. If you double the concentration of A, the rate will quadruple. It will increase by 4 times. And then there's a third order as well, and that order is the third one. Is it just one? Just hold on 1 second. अच्छा ठीक है. Because they've actually changed the board layout, so I'm a bit confused with the working of the board. As anyways, so this is fine. I said let's start talking about order, the third one, which is order 0. So what does order 0 mean? So order 0 means I said this one. So order equals 0. And what does that indicate? Just 1 second. See, मैं off कर दूं, my device stopped working. We'll talk about the other things later, but as right now, let's talk about order 0. So order 0, what is order 0? Order 0 is that rate. So I've got rate, and that's proportional to the concentration of my reactant, but the power is 0. And what that indicates is, what does power 0 mean? So that indicates that no matter what you do to the concentration of A, there'll be no effect on the rate of the reaction. Whatever you do to this, nothing changes. Nothing happens to the rate of the reaction, because anything to the power 0 is the same thing. Like if the concentration of A is doubled, power is 0, that means it's still going to give you 1. Okay, so Bilal, I don't get what you're saying talking about K. You haven't even started talking about K. I haven't even mentioned constants, anything. We will just stick to orders at the moment. Okay, what does an order mean? If you can, As we haven't talked about any other thing. We're just talking about what does order mean. Okay, that's it. Okay, we'll talk about everything else later on. That's in this one. So rate, that means changing concentration will not affect. So changing concentration it will not affect the rate of the reaction. So rate would kind of be constant. Nothing will happen to it. There'll be no change on the rate of the reaction if the order is zero. So you've got three orders and you have to understand what an order is. It determines the relationship that the reactant has with the rate of the reaction. One indicates that it's directly proportional. Two indicates that you double the concentration, the rate will increase 4 times. So there's going to be a square relationship. I mean, we can make a graph for this. It's going to be a quadratic. It's going to be a curve that will be pointing upwards. Okay, so the graph for this will be, it's going to go up. The rate will exponentially increase if you increase the concentration of A. And the last one over here is 0. That means nothing will happen to the rate no matter what you do to the concentration of A. So rate will be constant. It's going to be a straight line. There'll be no change on the rate of the reaction. Okay, so the rate would kind of in a way remain constant no matter what you do to the concentration of A. So three different processes. That's three different processes and you've got three different orders. So is this clear? Just the order part. Is that clear? So I'm building on top of this. Building on top of this. So now the next question is how do you actually figure out what order is? Like how do I know what is the order of reaction? Like if I have a reaction and I've got a simple reaction, I've got NaOH, and that NaOH is reacting with HCl, and they end up producing NaCl plus H2O. So the question now is, how would I know what the order of the reaction is? So I've got, I know that I've got two reactants involved. So I know that the rate would depend on the concentration of NaOH, right? So I'm going to mix NaOH and I'm going to mix it with HCl. So I know that collisions will happen between NaOH and HCl and there's going to be a reaction. I just don't know what the order is. I don't know what X and Y are. Okay, so the question is, how do I figure out? I mean, the whole chapter is all about this. So the question is, how do I figure out what X and Y are? What are the orders? Whether it's order 1. If it's order 1, that means, let's say X has a value of 1. What that means is that you double the concentration of NaOH, the speed of the reaction will double as well. It might be 0. That means if it's 0, that means no matter what the concentration of NaOH is, there'll be no effect on the rate of the reaction. And then you've got order 2, which means that you double the concentration of NaOH, the rate becomes 4 times. So you've got 3 orders now. So how to figure out, that's the next part. So there are 3 methods, 3 different methods. So there are 3 methods to find out order. And starting with the first one. So method number 1. Method number 1 is all about, method number 1 is if you know the mechanism, now you don't know the mechanism of most reactions. So if you know the mechanism, you can find out the order of reaction. Okay, so that's method number one. So we'll explore that method first. So for example, and remember, you can't figure out the order based on just the equation. You need to know the whole mechanism, how the reaction is done. So we did, I think, an SN1 mechanism in AS. So we're going to explore that and we're going to try and figure out what the order is. So SN1 mechanism is that you had a halogenoalkane. So I'll give you the mechanism. I'll first write down the overall reaction. The overall reaction was that you had a tertiary halogenoalkane. अच्छा उस केस में you had a tertiary halogenoalkane and you reacted with OH ions and they underwent a reaction and the Cl got displaced by OH. So it got displaced by OH. That was the reaction. That's a simple reaction, right? And you've got two reactants. So you got two reactants. One of them is this one. The other one is OH minus one. So obviously we know that the rate of the reaction will depend on these two things. We know that the rate equation will be that it's proportional to the halogenoalkane. Okay, so it's proportional to the halogenoalkane and its concentration, and at the same time, it's proportional to OH minus one. So it depends on the concentration of OH minus one. We just don't know what X and Y are. Okay, so we're going to try and figure out X and Y, the orders of the reaction, the way they're dependent on the rate of the reaction by focusing on the mechanism. Now, if you remember the mechanism of this reaction was that, what was the mechanism of this reaction? It had two steps. So this particular reaction had step number one. And step number one was where the carbocation was formed. So the CH3 Cl, in the first step, the Cl dissociated. And it ended up forming a carbocation. So I've actually drawn this incorrectly. There's supposed to be a Cl, a carbon over here. Let me just quickly add that. So there's going to be a carbon and there's going to be a carbon over here as well. Just 1 second. So you've got a carbon and then you've got an OH. Anyway, so, and there's a C over here as well. Just a second. So there's a C over here as well. Anyways, because there are 3 methyl groups attached to this carbon atom, right? So then you've got a Cl. Anyways, so that's the first step. A carbocation was formed. And let me draw the whole, draw the displayed formula just 1 second. Okay, let me draw the displayed formula. That would be much easier to understand. So you had a carbon and it had 3 methyl groups. And it had a Cl. The Cl was the first to actually break away. And that left you with a carbocation. So you had a carbon with 3 methyl groups and this one had a positive charge and the Cl has left. So it's formed Cl minus 1. Okay, that was step number 1. Remember, the mechanisms would always be given to you for this question. So you don't have to remember any particular mechanism. They will give you in the question. Now, step number 2 is, once that carbocation has been formed, so once that carbocation has been formed, the OH minus 1 then comes in and attaches to the carbocation. So you've got CH3, then you've got C. Now that's your entire mechanism of this reaction. 2 steps. And don't worry, this mechanism will be provided to you. Okay, so you don't have
So
to.
why is the product? Why does the product have Cl when OH is being added?
Sorry, OH. This is OH. Achha, but is this mechanism clear that you already did this mechanism? So that's your AS mechanism, right? Achha, anyways, our task was, how do we figure out the order? Because I told you that the rate depends on the concentration of one of the reactants and the other reactant. We just don't know how it's exactly dependent on that. So I'm going to explain how it's dependent. I'm going to give you the orders. The first one, for this one, it's 1. Okay, for this one, it's 1. And for the other one, it's actually 0. So how did I figure that out? पहले तो वो understand कर लो. That means what this means is that the rate depends on the concentration of CH3Cl, and it's directly proportional to it. You change concentration, the rate will increase. OH minus 1 having an order 0 means that it's not dependent on the rate of the reaction. So no matter what the concentration of OH ions is, the rate will not be affected. Any concentration to the power 0 is 1. So there'll be no effect on the rate of the reaction. So anyways, how did I come up with 1 and 0? So when you have a multi-step reaction, and most reactions are multi-steps, they happen in multi-steps, even though the equation is a single equation, but the steps of the mechanism, they involve multiple steps. Some of the steps will be slow steps. In this case, the first one is the slow step, and some of the steps will be fast steps, which means that they happen quickly. So as an example, the first step, the slow step, takes 100 seconds. The second step is just hypothetical values. So the second step is much faster. It takes 1 second. So if the first step is taking 100 seconds and the second step is taking just 1 second, the rate of the reaction will not speed up if you speed up this step. Like what is the overall time for this reaction? Right now it's 101 seconds, right? I mean, at the moment it's 101 seconds. 100 seconds for the first step, and then you have the second step, and that will require another second. So that's 101 seconds. The carbocation gets formed, and then the carbocation attaches to OH minus 1. That's a very fast step. So anyways, that's the overall reaction. Now remember, the rate of the reaction is not dependent on the fast step, because even if you speed up, if you try to speed up the fast step, let's say the fast step is now even faster, and now it's taking 0.001 second, right? What will happen to the overall speed of the reaction? There's hardly any change in the overall speed of the reaction. The first step is still taking 100 seconds, and the second step is taking 0.001 seconds. So that means the overall time required is pretty much almost the same. I mean, so there's almost negligible time change happening if you try to speed up the fast step. So is this idea clear that the fast step, no matter how you try to speed it up, it will hardly affect the time taken for the reaction to happen? Yes, Bilal, obviously it would have higher activation energy, but we're not going into that detail. We just know that a reaction is happening in multiple steps. Maybe there are 3 steps, maybe there are 4 steps. Some of the steps will be quick and some of the steps will be fast. So in this case, so we're not going into the details why it's slow. I mean, there could be a number of reasons why the first step was slow, because breaking the Cl bond requires some energy. So maybe the activation energy is very high, so which is why it takes a longer time. But a positive ion getting attracted to a negative ion will happen very quickly. So this one is a lot easier to happen. So maybe it's taking a very small amount of time. So there could be a number of reasons why one of the steps is fast, the other, but we're not going into that discussion at the moment. Achha, but everyone, is this idea clear that the rate of the reaction isn't really dependent on the fast step? No matter how fast you make the step, the overall time that the reaction will take, there will hardly be any change in that. Okay, is that part clear? You clear, Alicia? Anna, is this clear? Anya, is this clear?
Yes, sir.
Anyway, so the point is, the rate or the speed of the reaction, it depends on the slow step, not on the fast step. So not on the not on the fast step. It depends on the slow step. So it all depends on the slow step. So if I speed it up, let's say I double its speed. ये तो clear हो गया कि you increase the speed 1,000 times, you increase the speed 10,000 times. Hardly any difference in the overall speed of the reaction. If I just double the speed of this reaction from 100 seconds, it goes to 50 seconds. Now, all of a sudden, your reaction was taking 101 seconds, and now it's taking 51 seconds. So there's a noticeable change in the overall speed of the reaction. So everything depends on the slow step. Nothing depends on the fast step. So the question is, if you want to speed up the reaction, or the rate of the reaction, it will depend on the reactants that are involved in the slow step. So what are your reactants that are involved in the slow step? There's only one reactant which is involved, which is this one. So that means if you increase the concentration of this reactant, the slow step will speed up. So that means the rate of the reaction is only dependent on the reactants that are involved in the slow step. It will not be dependent on the reactant that is involved in the fast step, because OH ions are involved in the second step, which is the fast step. OH ions have nothing to do in the first step. OH ions have everything to do in the second step. So if you increase the concentration of OH ions, what are you doing? You're increasing the speed of the fast step. Nothing will happen. The overall speed will pretty much remain the same. So that means the rate of the reaction is not dependent on reactants that are involved in the slow step, in the fast step. Because if you increase the concentration of OH ions, yes, the fast step will speed up. But speeding up the fast step will have no noticeable effect on the overall speed of the reaction. So it's completely pointless to speed up the fast step. So that means the rate of the reaction will not get affected if you keep on increasing OH ion concentrations. But the rate of the reaction will be affected significantly if you increase the concentration of the reactant in the slow step. There'll be more collisions. Instead of taking 100 seconds, it might take 50 seconds because of that. And that's why the reaction overall will speed up. Okay? So is this part clear, that why this is order one, and why this is 0? Is that clear? Shian, clear? Jana? Anya, Bilal, Anna, is this clear? So we're gonna practice this in a lot more detail. So remember, rate depends on slow steps and any reactant that is involved in the slow step. So any reactant that's involved in and any reactant that's in fast step, that's order 0. Huh, Alicia, that's a good question. Why, like, how do you figure out whether it's one or two? TK. So we're gonna talk about that in the next class now, TK, because we're out of time. So we're gonna talk in a lot more detail. Like I figured out that that rate depends on this, but is it order one or is it order two? That's a question. That's a big question. So we'll answer that as well. Uh, like how much does it speed up when I change the concentration of this reactant? So first thing, any reactant involved in slow step, that's that's going to be given order one. That means rate is dependent on that. And any reactant in fast step, that's order zero. That's it. In fast step is order. So where do we get order two? That's an important question. So we'll talk about that in the next class, okay? But the main idea is the same. You'll just focus on the slow step. Any reactant involved in the slow step, that's order one. Anything that's involved in the fast step, like your reactants, the rate of the reaction will not depend on them, and they will be order zero, like OH ions in this case. So is this perfectly clear?
Sir, could you write that down, please?
Which thing?
The reactants and products order one and order two, please.
Yeah, I wrote it down. Any reactant involved in slow step, that's order one. Any reactant that's found in the fast step is order zero. The rate of the reaction will not be dependent on that reactant. You increase the reactant concentration, the fast step speeds up, but speeding up the fast step is kind of pointless. It will not affect the speed of the reaction. Okay. Anya, clear? Perfectly clear. Is this clear? Anna, Alicia?
Yes, sir.
वो याद रखो, I haven't talked about order two right now. ठीक है? So we'll talk about order two in the next class. चले ठीक है. Let's continue tomorrow then. Okay, everyone. Allah Hafiz.